Car Crash Investigation by Bella Roma, Abby Swain, and Misty Smith.
This is the diagram of the accident showing the direction of travel, which is to the right, the impact point, and both cars' skid marks, the SUV skid marks being 2 meters and the wagon skid marks being 24 meters.
Here's the diagram with the known variables. Here's the impact point. The Escalade skid marks are 2 meters, which is the displacement. We do not know the initial velocity. The final velocity is 0 meters per second because the car stopped, and the acceleration is -2 meters per second squared because the car is slowing down. For the wagon, here's the impact point. The skid marks are 24 meters, which is the displacement. We do not know the initial velocity after the impact point. The velocity is 0 meters per second because the car stopped, and the acceleration is -3 meters per second squared because the car is slowing down.
These are the calculations to find the initial velocity of the impact, or after the impact. We use the formula v squared equals the initial velocity squared plus 2 times the acceleration times the displacement to get the result of √8 for the Escalade, and using the same process, 12 meters per second for the wagon.
We use the conservation of momentum in order to find the velocity before the collision for the Escalade. So we plugged in the mass of both Escalade and wagon, plugged in 0 meters per second for the velocity of the wagon because the car was at rest, and we plugged in the velocities we found for after the collision. Our velocity for the Escalade is 10.83 meters per second.
These are the velocity time graphs for both cars. For the Escalade, this is before because it was traveling at a constant velocity, and from the impact point on, the car is decelerating to a stop. For the wagon starts at a velocity of 0 meters per second, and at the impact it accelerates and then decelerates to stop.
Here we have the energy diagrams for the Escalade. Before the collision, there's initial kinetic energy. During the collision, there's negative work because the Escalade is going opposite of the force. The resultant kinetic energy is positive because energy is always positive and the car is still moving after the collision. The work is negative with the brakes because the Escalade is going opposite of the force of the brakes, and the final kinetic energy is 0 because the car stopped moving. For the wagon, the energy diagram shows that initial kinetic energy is 0 because the car was initially at rest. After the collision, the work is positive because the wagon goes in the same direction as the force of the SUV colliding with it. The resultant kinetic energy is the same as the work because, and the work with the brakes is negative because the car goes opposite direction than the force of the brakes, and the final kinetic energy is 0 because the car stops moving. The type of collision is inelastic because in both situations the kinetic energy is not conserved.
The Escalade was going 10.83 meters per second before the accident.
The speed limit is 35 kilometers per hour, which is 9.72 meters per second. So yes, the Escalade is speeding by 1.11 meters per second.